Welcome back. In this video, we're going to see if we can detect whether or not SCARFY is colliding with any of the nebula hazards. Let's get started. Now, Raylib has a function called checkCollisionRex. It takes two rectangles and returns a Boolean, which is true if those rectangles are colliding. Now, before you get mad at me, I know I made you do this the hard way back in the Axe Games section, but I did that so you can understand how collision detection works. Now that you understand it, we can use the Raylib function to make our lives a lot easier. Now, how can we check to see if SCARFY is colliding with any of our nebula hazards? Well, each frame, we can loop through each hazard in the nebula array. And we can do this using something called a range-based for loop. This is a range-based for loop. For each element in the nebulae array, we're creating a temporary variable called nebula, and the loop body is executed for each element in the array. So say we have a Boolean called collision initialized to false just outside the for loop. Well, inside the for loop, we can check for collision. If we have a rectangle that represents our nebula's current position and dimensions, we can check that against SCARFY's rectangle, and if we reach the inside of this if statement, then checkCollisionRex has returned true, and SCARFY has collided with one of the nebula hazards, and we can set our collision Boolean to true. So I'm going to go down into our while loop. And just before we draw our textures for the nebula and SCARFY sprites, I'm going to create a Boolean called collision, bool collision. Now I'm going to use braced initialization, so collision is initialized to false. And then I'm going to create a range-based for loop. So we're going to say for animdata nebula with a single colon followed by the array nebulae. Now we can check for collision. Now we need a rectangle that represents the nebula's position and dimensions. So I'm going to call this nebrec. Now I'm going to initialize this. Now a rectangle has an x, a y, a width, and a height. For the x and y, I need to use the nebula's position. So we're going to get nebula.pos.x for the x and nebula.pos.y for the y. Now for the width, I'm going to use nebula.rec.width, and for the height, I'm going to use nebula.rec.height. Now, if you're wondering why we're not just going to use the nebula's rec member variable, remember the rec is what we're using to select the sprite from the sprite sheet. So its x and y are not representative of the nebula's position on the screen, but rather its position in the sprite sheet. So this way, we're actually getting our nebula's location on the screen. Now here is a nebula sprite, and I want you to notice that there's a little bit of padding around the nebula, which means we'll get a collision if SCARFY even gets close to the nebula. So we can fix this by creating a smaller rectangle around the nebula, more representative of the nebula's actual bounds. I'm going to do this by creating a float called pad. And I'm going to initialize pad to a value of 20. And I'm going to set the x to nebula.pos.x plus pad. And I'm going to set the y to nebula.pos.y plus pad. And now the upper left corner is going to be shifted to the right by 20 and down by 20. Now I'm also going to alter the width and height. This nebrec rectangle is going to have a width of nebula.rec.width minus 2 times pad. And I'm going to set the height to nebula.rec.height minus 2 times pad. Now remember, we're squeezing in that upper left corner by 20 in the x and 20 in the y. Then our width and our height must be 20 less on the left and 20 less on the right, as well as 20 less on the top and 20 less on the bottom. So the width and height must be lower by pad times 2. So now we have a collision rectangle for the nebula. we also need our Scarfy rectangle, so we're going to create a rectangle called ScarfyRec. And for this one, we're going to initialize it using Scarfy data. So we're going to use scarfydata.pos.x for the x and scarfydata.pos.y for the y. Now for the dimensions, we can simply use scarfydata.rec.width and scarfydata.rec.height. Now we don't really need a pad for the Scarfy sprite, as the Scarfy character reaches all the way to the edges of each animation frame. So now we can call check collision rex. So we're going to use an if statement and use check collision rex, first passing in nebrec for the first rectangle and ScarfyRec for the second. And I'm noticing I have a typo in my variable ScarfyRec. This should be a y. And if we've reached the inside of this if statement, then we have a collision. So we're going to set collision equal to true. So now for your challenge. I want you to check the collision variable with an if statement. And if it's true, don't draw the textures. But if it's not true, draw the textures. This way, we'll stop seeing Scarfy in the nebula hazards if we have a collision. Pause the video and add this now. Okay, so I'm going to scroll down to where we're drawing these textures. And just above, we're going to add an if statement to check collision. Now, if collision, then we know we've hit a nebula and we're not going to draw the textures. In fact, this is when we would lose the game. So we're going to add a comment that says, lose the game. Now, in the else statement, we're going to draw the textures. So let's highlight the code where we're drawing the textures, copy it, and delete it, and we'll paste it into the else statement. I'm going to highlight these lines that didn't indent and hit tab to indent them. Let's go ahead and hit run and start debugging. Here's Scarfy, and boom, we hit a nebula and we stop drawing the textures. And we can also tell that this padding value could be a little higher. Let's bump it up to 50. Great job. Now notice that Scarfy comes back once we're no longer overlapping. We can fix this by taking our Boolean called collision and moving it all the way up outside the while loop. So we can place it right here just above set target FPS. Now if we hit run and start debugging, whenever we get a collision, Scarfy will disappear and never come back because we're initializing collision to false and we're never setting it back to false once we set it to true. So in summary, we created a Boolean called collision, and we're setting this to true if Scarfy overlaps with any of the hazards in the nebulae array. We now have a value for losing the game.